right, we are back. Last unit of the year. It's a sad day. It's a sad day. The lessons are dwindling down now. I mean, really, just a lot of tears today for this unit and being the end. But a video made by me as promised. All right, it's very exciting stuff. Yeah, right. All right, try to contain your excitement for the sub, just so they don't like freak out that you guys are all screaming and yelling when you're watching this video. Okay. But we do have one more test, question mark? Yes, of course. One more unit. Today we're evaluating limits at a point. This is going to be some fun stuff. All right. Song of the day actually playing in the background. Yeah, that's pretty techy. I know. Yeah, for sure. All right. But great song. All right. Brand new album by Leon Bridges just came out. If you're into that, I would definitely recommend listening to it. Okay. But let's do some math. That's what we're all here for, right? So, evaluating limits at a point graphically. What? So what is a limit? A limit is a value that a function or sequence approaches as the input or index approaches some value. Okay? So as x goes to a number, y is approaching something. Okay? So, excuse me. Okay, come on, dude. Alright, so let's say I have this graph. I don't know, I'm going to make something up. Let's put a little, let's do a hole at 2 and get it from 2 and going off. And then let's maybe have a little jump action going on here and go something like this. And I'm just making something up here. Alright, I just made something up. Okay, that's just some function. So you're going to see a lot of these things. Okay, the limit as x approaches to, and I'll talk about what all this notation means. Okay, or the limit, and that would be of f of x would equal -1. And you're going to be like, what are you talking about? Don't worry, I'll explain it in a couple slides here. The limit as x approaches to from the right of f of x is about 2. Okay, the limit as x goes to 2 of f of x does not exist. Okay, so what does this mean? Alright, well, first of all, these two have to match for this to exist. Alright, and you're like, Mr. McConey, what are you doing? I know, it's going to be explained. This is just some notation that you're going to see. So this notation, the limit as x goes to some constant c, where there's a negative like that. All right, the negative denotes look at it from the left. Limit of f of x as x goes to c. So that means from the left. All right, this is a little calculus action going on here. It's not really calculus. It's a little intro to calculus. Okay. Well, Mr. McConey, why do we need to do this? I'm so done with math. Oh my gosh. Oh my gosh. That's alright. So the limit as x goes to c of the plus, that means from the right. The plus means right, the negative means left, right? Because the negative number's on the left, the positive numbers are on the right. Okay, and then it'll be of f of x. Alright, let's see. Or you can also have the notation limit. What does that say? I don't know. That should. Limit as x goes to some constant c of f of x. And this is just overall. The overall limit. Overall. Okay, the overall limit. Alright. So how would I read this? Okay, I've been saying it out loud. This is read as saying, you could say it as the limit. There you go. As x approaches c. And c will obviously be a number in the future as x approaches some constant. The limit as x approaches c. Okay? Very hard to write on these things, so bear with my handwriting, even though it's never really that good. In general, but hey, when you know, you know. Okay, so we know. So in order for a limit to exist, okay, the limit, it must exist from the left and the right, and those limits must be the same. So what that means is my left-hand limit, so remember this A with a little negative is from the left, B with a little positive means from the right, and they must equal, if they both equal the same thing, like let's say, I don't know, we'll just say the limit is equal to the limit, for sure, L. If they both equal some limit L, then the overall, remember this is the overall limit of f of x at that letter, or at that constant, will be L. These will be the same. If these two match, then this exists. Okay? If they don't match, if not, you write D and E for does not exist. Alright, I write D and E for does not exist. If not, D and E. Okay? Am I missing anything? No, I think I'm good on that page. Alright? So let's try one. What does this mean? Okay, so I'm going to look at my function. So this function is g of x. Alright? So it has a little negative up there in the right hand corner. Alright? Like a little negative, like an exponent almost. So I go to negative 2. As my graph approaches negative 2 from the left, my function is at negative 4. Little plus sign. As it approaches negative 2, x, remember looking at x, from the right, it's also negative 4. Well, if these two match, then I win, then my overall limit is negative 4. Okay? Watch that again if that confused you. Alright, so here's where it might confuse you again here. Alright, the limit as x approaches negative 4 from the left. So I'm following my function down to negative 4 from the left-hand side of that function. This part is on the left-hand side. Okay, it's less than negative 4. Alright, my function hits this point right here. Well, what is that value? That is 1. My function as f of x approaches negative 4 from the right, x goes to this value, negative 2. Well, these two numbers aren't the same, so their overall limit does not exist. The overall limit does not exist. Please rewatch it if you have some questions, alright, or if you have some issues. We're going to try another one. Alright, different function-ish, maybe. Probably not. Same function, different numbers. Solid, here we go. So, the limit as x approaches positive 2 from the left. From the left. So, positive 2. I'm coming at positive 2 from the left. Boom, I hit 1. As it approaches negative or positive 2 from the right. I'm coming at positive 2 from the right. Oh my goodness, I hit negative 2. Well, what does that mean? That means it does not exist. Hello. These aren't the same. Does not exist. Wow. Sorry, I'm just getting emotional. Last unit. Here we go. Oh my goodness. Alright. The limit as x approaches 6 from the left. Boom. Oh, it's 1. The limit as x approaches it from the right. No way. It's 1. So guess what? The overall limit is 1. So that's those two numbers match. Alright, let's try some more. I'm going fast. Pause it, rewatch it. Watch it as many times as you need to. The limit as x approaches 0. Why don't you, here's what I'm going to do. Pause it. Pause me. Alright, put me on hold for a minute, okay, and then you're going to check your work. So after you pause it, all my work will show up, okay? Here we go. Try this one. You go. Alright, check your work. Hopefully you're able to get that one correct. Or do that one correctly? All right. If not, make a star or something. I could answer a question on Monday about it. Okay. All right. Let's try this one. Okay. As x approaches -4 from the left. God bless America. Can that be read, please? Thank you. From the left. I'm running out of time here. I'm just having too much. Sorry, it was +4. So my graph is going down, down, down. So technically, all right, the limit goes to -infinity, right? All right, but that's not an actual value. So you can write -infinity, or you can write does not exist. Okay. The limit as x approaches 4 from the right goes up, up, and away to +infinity, or D and E, because it's not an actual value for these two. So these two don't match. So it does not exist overall. Okay. The limit as x approaches -8 from the left is 4. From the right is 4. So the overall limit is 4. Okay. These two are kind of confusing. If these two match, then we will have infinity. And I'll show you what that looks like. Where am I at? Okay. The limit as x goes to -infinity. So as x goes to -infinity, as x is going off here, y is doing what? Y is getting really big. So that's why our function is going to infinity. Okay, and some people may write does not exist. I'm going to tell you on Monday what I want you to do with that. Okay, the limit as x goes to +infinity is going down, so that's -infinity. Okay. Now these are actual points here. Okay, so now I want to find these ordered pairs. G of 0. Well, where does our function, like when I plug 0 in for x, what do I get out for y? So I go to 0 for x, and I look at this point. Is there a point there? Yes. So x is -1. Okay, G of -4. Go to -4. All right, there's a hole down here, and there's an actual point, a coordinate right there. So I would say 1. Because of this hole, -4, x does not equal -4 at this value. X equals -4 right here. At the hole? No. Not at the hole. All right, 6, +6, close dot, that's 1 as well. And then what color? Wish there was like a, we done purple? Yeah. Let's go navy. All right, so I want G of 4. All right, +4. Well, there's this asymptote here. You see that? There's that asymptote there. So that means x cannot be 4. So this does not exist. X, if I have an asymptote at 4, then x cannot equal 4. That's what that means. So it does not exist there. All right, the limit, or the actual function, actually not the limit, but the actual function does not have a value of x equals 4. All right, so conclusion. When evaluating a limit, the answer is always a y value. Okay, as x approaches a number, what is y approaching? As x approaches, as x approaches -8 from the left, y is going to 4. As x approaches 8 from the right, y is going to be 4. Okay, the limit only exists if the function, the y value, approaches the same value from both sides. So here it approaches 4 from the left, 8 approaches 4 from the right, so the limit actually exists. Okay. You don't have this. I don't know why this is on here. All right, but you could do this for fun if you want to take a picture or write this stuff down. I didn't put it on your actual sheet there, but your homework, all right, will be that yellow sheet. All right, once you finish with that, if you have any corrections that you need to do for your Unit 4 test, or your Unit 2 test, or your Unit 3 Part 1 test, you can be working on those. The Unit 3 Part 1 test was a chapter test, so only hand in 2 sets of corrections so I can grade them, give you both a grade. If you have a question, feel free to email me. I'll have my phone by me all day, but have a great weekend. For those of you going to prom, enjoy, and I'll Talk to you on Monday.